बस
इस पे मिनिमाइज शेयर करने के लिए सर
ये वाला ना
पावर के बाद हाँ एडी में हाँ नहीं हो गया
आप कर देंगे 12 बजे लेट्स स्टार्ट जब लोग ज्वाइन करते रहेंगे बैकग्राउंड में क्या
कोर्स के बारे में 2-3 मिनट के
अच्छा फीडबैक लास्ट में ले लेंगे पहले क्वेश्चन अगर उनका हो तो वो क्लियर कर लेते हैं 12 बज रहा है ना स्टार्ट Good afternoon, all of you, and welcome to this live session of Cryogenic Electronics for Quantum Computing NPTEL course. For your information, this is being recorded also. I think two people of you have joined, Sriram Subramaniam and Rahul Kapse. So before we move forward, you can either speak out about the question which you have or any clarification, suggestions, and we will try to respond to that and followed by your feedback for the course. So if you have any questions, please let me know.
Sir, good morning, sir.
Good morning. Good morning.
I am very happy to see you, sir. Your lectures are very excellent.
Okay, thank you.
And each and every video that you have tweeting is excellent, sir. And I have only one doubt, sir. Is there any simulation-based things that we are going to see now, or only this kind of theory?
Simulation, I might add some tutorials on simulation later on. As of now, we are only sticking to the theory because for cryogenic electronics, there are no simulations which are, there are no EDA tools which take up cryogenic for the time being. There are no stable EDA tools or TCAD tools which take care of these things. So that's the problem which we are facing as far as simulation is concerned. So what people generally do is that they use the standard EDA tools like Synopsys or Cadence, and for TCAD, Synopsys and Cadence, and then they try to change the physics files by inserting the cryogenic elements. But that will be difficult in this scenario because these are all term-based licenses, and therefore it will be difficult for us to do it. But nonetheless, it's a good point you have raised. I will try to do that in the remaining few recordings which we can do. Maybe 2-3 extra recordings can be taken care of for introducing the simulation as well. Thank you for your suggestion.
Thank you very much.
Rahul?
Yes, sir. Very good morning, sir. I am Rahul Kapse. I am an associate professor at Pillai College of Engineering.
Okay.
Pillai HOC College of Engineering and Technology. Sir, I did
This is
two courses previously. I did 2 courses previously: Introduction to Quantum Computing, and then Quantum Computing, Cryptography, Quantum Algorithms and Cryptography. 2 courses I did previously. And I am also started one startup, that is Reverend Koi LLP. I registered that in December 24. I am from computer engineering background, sir.
Okay.
And while working in startup, as well as along with that, I'm associate professor at in college. So, what I can go ahead in, how we can progress, how we can do the task in company, and what should be the roadmap for me? Basically, I'm struggling to where to start and how to start.
So I believe startup is sort of 100% you have to give your time, right?
Yes, yes, yes.
It will be very difficult uh, if you do both the things together. So my suggestion would be, if you're interested in the startup and the startup is showing some amount of clarity in terms of objectives and you're able to get funded relatively easily, then
Mm-hmm.
you should invest your time more into the startup rather than your faculty teaching.
Mm-hmm.
While I understand that startups, generally most of the startups fail, there are very few startups which actually
Mm-hmm.
succeed.
Mm-hmm.
But but I can understand doing both the things at the same instant of time is a very difficult task, right? Because there is always a
Mm-hmm.
bandwidth issue for all of
Yeah,
us.
I can facing that difficulty also. But along with that, I am having the number of students. Students, I can provide the internships and all those things them. And the way I got the time, I will work on it. But still, I'm not getting the manpower uh, in the field of quantum computing.
Okay, okay. So it's I agree with you that as of now in India, trained manpower in the domain of quantum computing, be it the hardware part or the software part, is very difficult. And
Mm-hmm.
because there is no bachelor's program in India which does with quantum, and there is a reason for that. This is because it's a new field first of all, and it's a very very niche field. Where niche field in the sense that it is unlike traditional electronics, mechanical, civil. This is very
Mm-hmm.
very niche field where knowledge base has to expand too much in order to even start the work, right?
Mm-hmm.
So as of now, I agree with you that the manpower requirement in country is not there. But
Mm-hmm.
an interesting part has happened is that government of India through its programs uh,
Mm-hmm.
encouraged tier 1 and tier 2 institutes and even tier 3 institutes to start
Mm-hmm.
maybe a basic course on quantum computing.
Mm-hmm. Okay.
So in next maybe couple of years or maybe 3 to 4 years, you will see some amount of input coming here. It was something like this when VLSI initially started. There were very
Mm-hmm.
low amount of trained manpower, at least from the universities.
Okay.
Now there is a substantial amount of manpower after 10 to 20 years, 10 to 15 years, because of regular input from the university onto the ecosystem. In my understanding, the same is true even for the quantum world. You will not
Okay.
get very large amount of trained people, but then since you're an expert in that domain, you can start creating your own manpower using the students in your institute. So I
Okay.
would believe that for you to move forward, a good idea will be to train the manpower to reach to a level where they can take up the work of the startup, and
Mm-hmm.
and also make them also better trained so that they are a better workforce and this thing in the coming years. I understand that India still has a long way to go in the area of quantum dimensions, but there is a national quantum mission which has been launched by DST, uh,
Mm-hmm.
and that will go a long way in fulfilling many of the wishes of quantum computing, quantum cryptography, quantum materials. So there are large areas in which projects have been given under NQM mission, National Quantum Mission, and to a
Mm-hmm.
larger extent they will go in fulfilling the wishes of many people in India and making us India maybe a powerhouse in terms of quantum computing, right?
Okay, sir. What problem I'm facing while in teaching also, students are not interested to learn quantum computing.
There is reason for that. You see, to learn quantum computing for that matter, you require to have a substantial amount of background knowledge.
Mm-hmm.
uh, Students as of now are more interested in the areas of coding and all those stuff,
Mm-hmm.
AI and machine learning, because that seems to be lucrative for the student, right? From point of view of
Mm-hmm.
getting a job or point
Mm-hmm.
of view of getting a proper job, right? Quantum is
Mm-hmm.
still, as of today, learning quantum computing per se, there are no large amount of jobs available in India If you look from,
Mhm.
if you look in a very narrow sense from the point of job, then um, there is no scope, very limited scope in terms of quantum. However, this is going to increase drastically in coming years, right? And
Okay.
that will take up, and that's the reason it requires a lot of rigor. In quantum, it requires a lot of rigor because certain concepts you need to develop, right? You
Mhm.
Before you even start understanding the nuances of quantum computing, you need
Mhm.
a good amount of research, good amount of understanding of basic areas of quantum domain, and then you can work here. So that might be possibly the reason, as you rightly pointed out, was that the students are not too much interested in this one. But if you can give them good problems, no, I don't think they will not be interested. If you can give them good problem statements, if you tell
Mhm.
them to solve a small problem using quantum computing, they will be quite interested to do it. I am supposing, at least for where I belong, where, for example, I am in IIT Roorkee. There are many people who are interested to work in the cryogenic electronics, for example. So my
Mhm.
TA is there, Shakir, and Shakir has been we have been mentoring quite a few BTech, MTech students in the area of quantum computing, especially in the cryogenic electronics.
Okay.
So there are interests coming up slowly but surely. But I agree
Mhm.
with you, there is a manpower shortage, and the students are not very much interested at the first go to do it.
Okay.
So that is the
Okay.
problem, right?
Okay. Okay. Thank you, sir. I will share my company's website link on chat box. If you get time, you can just
No,
go
just
through
drop
it.
me. No, just drop me a mail, right? You can even drop me a mail.
Okay. Okay.
Give me the name of your company's your web page, and
Okay. Okay.
we can have a small discussion, a one-to-one after
Okay.
that, right?
Okay. 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 Thank you, sir. Thank you very much.
Thank you, Dal. Thanks a lot.
Okay.
Yes,
Sir,
yes, Srinam.
sorry, sir. Actually, again, I have some one more
Please go ahead. Please go ahead.
clarification. Sir, actually, now we are discussing about the electronics which we needed to acquire the signals from the qubits, right?
Correct.
As well as controlling.
Correct.
Uh, uh, can we see anything which is because basically I'm a material science based person, and I'm working as an assistant professor here in Sastra University, Tamil Nadu. Actually, my area of interest is developing materials for these spin qubits and semiconducting superconducting qubits. Can we see anything related to that
Yes.
in our course?
In our course, no. I'm not a materials person, and therefore, I am not the right person to give you any advice or suggestion on material side of it. There
Okay.
are colleagues of mine who are working in that domain.
Okay.
As I was just telling Rahul about this national quantum mission,
Yes, sir.
within this national quantum mission, I believe there is a materials group who are working primarily on the substrate material for qubits.
Yes.
So I think that group belongs to either IIT. I think IIT Bombay to the larger extent. That
Okay.
hub belongs to IIT Bombay. In that hub,
For quantum material device, it is IIT Delhi, I think, sir.
maybe IIT Delhi, maybe because I we belong to IIT Delhi, right?
Oh, yes, sir.
So we belong to IIT Delhi, but there are two groups in IIT Delhi. Uh, one is in the domain of electronics, which I head,
Okay, sir.
not I head. I belong to that team, and there is another which is headed by physics department. So
Okay.
you might be correct saying that uh, there might be also somebody from physics side at IIT Delhi looking after the materials angle of the qubit.
Yes.
You can send me a mail. I can connect you with those guys,
Yes, sir.
so that we know that so that it becomes helpful for you as well if
Okay.
they're working on it, right?
Okay. Thank you very much.
Okay. So anybody else has any questions? Medha Joshi. Yes, Medha, please carry on. We cannot hear you, Medha. Your voice is very low.
So I want to know about the fabrication prospect of qubits, like how what lithography processes and how do we fabricate such small qubits in our device?
I am not a materials person, so the answer might be slightly different. Whatever I know from the various people, I can tell you that. So
Okay, sir.
typically there is no large change in the litho or the fab process of these devices, apart from the fact that these are actually the substrates which they use is still silicon dioxide, silicon, and so on and so forth. However, you require for quantum dots, for example, you require a heterostructure
Okay, sir.
to generate these quantum wells, right?
Okay, sir.
Quantum for generating the quantum dots, you require quantum wells, and these quantum wells are fabricated using heterostructure. So you do have a mixture of silicon as a substrate and heterostructure for the purpose of quantum dots. So
Okay, sir.
that is what I know. I'm not a person of material science or even the
Um,
fabrication area. So that is what my answer is. A very limited
so
answer.
how do we control these qubits? Like
Okay.
we would need the mechanism to control these
Yes,
qubits,
yes,
right?
yes. There are mechanisms controlling it. You will see it in week 8, 9, 10, 11 of this course. But just
Okay.
to give you a brief idea, there are two ways of controlling this qubit. See, the very idea is when you generate a quantum computing, you have these qubits which are sitting at millikelvin, right? Now,
Hmm.
now, the basic principle of readout is that while you are reading out the qubit state, you should not change the state of the qubit while reading it. You get my point?
Yes,
Like
sir.
if it's spin up, let us suppose I have a spin qubit, I have a
Okay.
spin up. Now I try to read it from an external source, but we'll come to that later
Hmm.
on. But while reading
Hmm.
it, it becomes either spin down or spin flat. Then you are changing the state of the qubit while reading it. That is not allowed, right? So and this is basically a problem of decoherence which happens. There are two ways by which traditionally one does, and that is one is your through microwave pulses. These are very short pulses of few picoseconds, typically in the range of 4 to 8 gigahertz if you are using transmons, and around 12 gigahertz if you are using spin devices. And you send these short bursts of microwave pulse from an external source, and it strikes the spin qubit, and depending upon if it's spin up or spin down, it reflects back. Once it reflects back, you check its S parameter, S11, S12, S22, S21, and from there you can do a back calculation to understand the state of the qubit. This is one way. Another methodology is by optical methodology, where you shine a light onto the qubit. Again, the reflected wavefront comes. From the reflected wavefront, we check whether the state of the qubit is top or bottom. The challenge which you will face while readout is you need to ensure that not only you don't change the state of the qubit, but you also ensure that the nearby qubits don't get influenced by the signal which we are sending from outside. So let us
So,
suppose that, right. So if I
so
send
one thing. So
yes,
one thing, like I initially don't know the state of a qubit.
right.
So how
No,
I will ensure that whatever I am getting is the
correct.
state, right qubit or not?
Typically, when we design a qubit, we initially do what is known as an initialization of qubit. What does it mean
Okay.
is that by an external pulse, you very well know there is something known as block sphere, and by giving these Pauli X gate, Y gate, and so on, I can very well
Mm.
know initially what will be the state of the qubit. So initial state of qubit is known to me, right?
Okay.
So that solves the problem generally. Now, final state of the qubit, you are absolutely correct, not known to me. And that's the challenge of the readout circuitry. That the readout circuitry now needs to talk to the qubit without changing the state. So I'm assuming that all the transformation has taken place, the qubit is in its final state, and I just have to read it. Right. And then we send the microwave or the optical pulse to do that.
Okay, sir.
Okay, if anybody has any other question. Okay, fine. If there are no questions, then we can stop, right? Dharamveer,
Hello, sir.
please.
Sir, can we start to construct the quantum bits uh, that will work on room temperature? Because constructing the cryogenic chamber and all those things is very costly. And at college level, can we do such kind of experiment?
I am not. See, I will tell you why. So you must be knowing why we go to at such low temperature, because it gives stability to the qubit and it gives it removes the problem of decoherence, decoherence problem, right? Now, I'm not very sure if you bring it in the room temperature, there will be instability in the qubit. This qubit won't be able to maintain its states because of thermal energy which is available in the atmosphere. Are you getting my point?
Okay.
So that will always be a problem. So as of now, just like if you remember the superconductivity, superconductivity only works at very, very low temperature.
Yes, yes, sir.
Now there is a group of people or researchers working at room temperature superconductivity. So
Okay.
exactly like that, there are people who are trying to work at quantum at room temperature, but that's still a long way to go. I will be very clear with you and very frank with you that even cryogenic temperature quantum processing is rather very difficult and very costly. As you rightly pointed out. So
Yes.
each dilution refrigerator costs you basic around 10 CR, and therefore it is very difficult to put it in a college system or a university system, right? uh,
Okay.
at least in Indian scenario. So yes, there is a group of people who are working in it, but as of now, it seems to be very difficult, if not impossible.
Okay. Okay. Thank you, sir.
Thank you. Okay, if there are no further questions, shall we finish the session? Rahul, Sriram, and Medha. Okay, thanks a lot. Thank you very much.
Y- yes, sir. Thank you very much, sir.
Thank you. Thank you. All the best for
Sir,
all.
shall I send you mail, sir,
Yes,
regarding that?
sure, sure. Send me a mail. You
Okay.
have my mail, right? I can send you my mail ID.
Okay, sir.
Just let me. If on the chat box, I'm sending it to you, all of you.
Yes, sir. Thank you, sir. Thank you very much, sir.
Okay, thanks a lot. Thank you. क्लिप तो देखा गया
OBS पहले बंद करो स्टॉप रिकॉर्डिंग चलिए